Hi, welcome back to Algebra 2. Today's lesson 1.8 is on piecewise functions. So functions expressed algebraically can sometimes be more complicated and involve different equations for different portions of their domains. These are known as piecewise functions because they come in pieces. If all of the pieces are linear, then they are known as piecewise linear functions. And that's really what we're going to be concentrating on today. So exercise 1 gives us a nice example of a pretty simple piecewise function. As you can see, we have two situations. So we have y, think about it like this, y equals x minus 3 between negative 3 and 0. And then we have y equals 1/2 x plus 4 between 0 and 4. Now, if you look here, you can see how this is a less than sign, which means that our function y equals x minus 3, our linear function, is going to go up to 0, but it's not going to include 0. So this basically means I'm going to have an open circle here. And then we have the 0 here, which means I'm going to have a closed circle here. When you have the equal sign, you get the closed circle. When you have the strictly less than or greater than sign, you get the open circle. So let's take a look. Our first one. Why don't we do this one in green? And we'll do x minus 3. So between 0, I'm going to go kind of cut that 0 in half. So I'm going to consider this part being y equals x minus 3. And now I'm just going to substitute my values in. So negative 3 minus 3 is negative 6. Negative 2 minus 3 is negative 5. And negative 1 minus 3 is negative 4. And 0 minus 3 is negative 3. So what that means is our points in green from negative 3, 1, 2, 3, 4, 5, 6, from here to negative 2, negative 5, here, and when we get to 0, we're going to have an open circle. So that is what the green portion of our, which is this portion right here, of our graph, our function, is going to look like. Now let's look at the second half. We'll do that one in red. So we're looking at this part right here now. At 0, now this, let's write it up here like we did last time. Y equals 1/2 x plus 4. So when y is 0, we get 0 plus 4, which is 4. When x is 1, it's 1/2 times 1 plus 4, which is 4.5. And we're just going to leave it like this for now, or 4.5. When x is 2, you get half of 2, which is 1, and 1 plus 4 is 5. Half of 3 plus 4 is 5.5. And 4, half of 4 is 2, and 2 plus 4 is 6. Now again, you can get this table right off your calculator, so don't flip out if you're having difficulties doing the math in your head. Okay, because that's not what this is about. This is about being able to recognize what this function looks like. So let's graph the red now. So a closed circle at 0 means that at 0, 1, 2, 3, 4, I'm going to get a closed circle here. At 2, I'm at 5, and at 4, I'm at 6. And in between, I'm at the halves. So this is what this part of the function looks like. Kind of funny looking, right? But it's a piecewise function. State the range of f. So the range are the y values using interval notation. So basically, the y values go from here to here, and then again from here to here. So we're going to need an and in this one, which we haven't really seen before. So the first half, 1, 2, 3, 4, 5, 6, goes from this point, which is negative 6, to negative 4. So it includes negative 6, so I use a square bracket. negative 6, because it says to use interval notation, negative 6 to negative 4, but it does not include negative 4. So we're going to have a parenthesis there. Then we're going to use this sign that's intersection. Basically, this means and you could very easily also write the word and. And now we're going to consider the next part of our range, which is 1, 2, 3, positive 4 to positive 6 inclusive, which means it includes the positive 4 and includes the positive 6. So that's how you would write the range of this crazy function. Not only should we be able to graph piecewise functions when we are given their equations, but we should also be able to translate the graphs of these equations, of these functions, into equations. So in other words, if I give you a piecewise function, you should be able to write it in the format that was given to us. So finish writing down and then meet me at exercise 2. So the function f of x is shown graphed below. Write a piecewise linear formula for the function. Be sure to specify both the formulas and the domain intervals over which they apply. So as we can see, we have 3 different pieces to this function. We have, let's call it the red piece, from here to up here. I say here a lot because unfortunately I can't point it. The next one goes from here to here. And then the next one, the last one, goes from here to here. Now, obviously, if you look right in these spots, you see how I have 2 points there? Well, that can't happen because we are being told right here that this is a function. And we know that we can't have 2 points on the same line. So we have to make sure that we are making one of them an open circle. And this is the beauty of this part. Because they're asking us for this, we can decide what we want to do. So let's say, for example, of this red function, we're going to make the red function be an open circle here, and then we'll make the green be a closed circle. And we could do the same thing for the blue section. Let's make the blue section the open part, and we'll make the green the closed part. So once you figure those out, the rest of it isn't bad at all. So let's figure, we're going to write this down, make it look like this. F of x is equal to, and we're going to put this crazy looking squiggle here, because there's going to be 3 parts of this. We're going to have 1 part here, and then 2 parts, and then 3 parts. So the red is going to be the first part that we're going to look at. So now this red piece, it's a linear function. So what we have to determine is what is the equation of a linear function. Well, let's go back to remembering it's y equals mx plus b. B is where we begin on the y-axis. Well, if I look here, I have to figure out what the slope is. So if I look, it looks like it crosses here, it looks like it crosses here, and it crosses there. So my slope is up 3, right 2. Up 3, right 2. So that's my slope. So it's going to be up 3, right 2, and then we put the x behind it. Then we have to figure out where it crosses the y-axis. Well, it doesn't cross the y-axis, but if it continued, we go up 3, right 2, and it would cross right here. 1, 2, 3, 4, 5, 6, 7. So we're going to say positive 7 because that's where we would begin. And then if we kept going from here, we would go up 3, 1, 2, 3, right 2. So we'd end up over here somewhere. So if this continued, that's what that line would look like. Okay, now, once you have that down, let's move to the green line. Oh, we didn't put the domain in. I'm sorry. So I didn't think about that part. So domain, 1, 2, 3, 4, 5, 6, 7, 8. -8. It starts at -8 and it ends at -2. So we're going to say -8. I'm running out of room here. -8 less than or equal to x, which is less than, we're not going to put the equal to sign here, -2. Because we have an open circle at -2. So now we're going to do the green piece. So the green piece starts at -2. Maybe we could do this part too. First, -2, which is less than or equal to, because this it equals that, less than or equal to x, which is less than, the green piece is going to be the solid piece. It is. So green, so we're going to have another equal to sign, and it ends right here at +3. So that's our domain. But what's the equation of a horizontal line? Well, you can see here that it crosses at y equals 4. So we put just the number 4 here, because basically what that's saying is, if you think about it, how this works, this would be y equals, and y equals, and y equals. Of course, we don't put that part in because we have the f of x all the way on the left-hand side. All right? So we're going to leave it just like this. Now we're going to do that last piece in blue. Now, if I can do this very carefully, I am going to just try to get rid of this stuff right here. So we can play around with this a little bit better. All right, so now we're working on the blue one. Again, let's start with the domain because that seems to be easier. So the domain starts at 3, and because it's an open circle, we know it's going to be less than x. Notice these are all less than signs. And then it finishes at 3, 4, 5, 6. So right here it's 6. And it includes the 6, so we're going to have an equal sign underneath that. And now what's the equation of this line? Well, think about how we get from one point to another. We're going to go down. Let's see, where do these hit? It looks like it hits here. It hits here. So it looks like you go down 2, right 1. Down 2, right 1. Down 2, right 1. Notice how this is falling as you go from left to right. It's going in the downward direction, so I know this is going to be a negative slope. So I know this one's going to be down 2, right 1, and I'm going to put the x behind it. Now, what is the y-intercept? Because this one's going to hit. So again, we're going to just follow this up. Up 2 over 1, up 2 over 1. I'm off the graph a little bit, but up 2 over 1. So if I extend it a little bit, I can see how it hits it. 5, 6, 7, 8, 9, 10. And that's going to be my equation for my piecewise function. All right? The functions that read, this is called set builder notation. Remember, you could write this also in interval notation as 3, 6, because it includes the 6, but it doesn't include the 3. All right, usually we write this part in set builder notation like it's shown. And how we read this is x, we start with the x here and we say x is greater than 3, but it's less than 6. All right, but the less than sign says 3 is less than x. Remember, it always opens to the bigger value. So we can say x is less than 3, x is greater than 3, x is less than or equal to 6. I know it's kind of confusing sometimes, but we'll get to it. Hopefully you remember this a little bit from Algebra 1. Okay, let's move on. Exercise 3. Consider the piecewise function. Now, it says determine the y-intercept of this function algebraically. Why can a function have only one y-intercept? Well, hopefully you remember the reason this can only have one y-intercept. Let's say a function can have only one output for every input. And what is the y-intercept? Well, we have to look and see. Remember, if it says y-intercept, the first thing I write down is x equals 0. I do a lot of translating because translating helps me. Just like in any weird language, you sometimes will start with just translating it instead of being able to speak about it. So the y-intercept means x is equal to 0. So when I look right over here at my domain, I have to find which one of my pieces occurs when x equals 0. So what I'm thinking about is which one of those pieces is going to be happening when I look at my y-axis. Well, the first one says x is less than 4, and the next one says x is greater than 4. So I know that x has to equal 0 in this one right here. Okay, so when x is 0, so when x equals 0, g of x is equal to x minus 2 squared, which is equal to 0 minus 2 squared. Be careful because that's negative 2 squared, which is positive 4. If by chance you couldn't figure that out, then maybe you want to do B first. Even though it says to find this one, this says determine algebraically. Even if you can't do it, if you couldn't do it algebraically, do it graphically, because that will still give you some points. Remember, a 0 on any test is completely irrelevant and incomprehensible. So as long as you're showing that you know what you're talking about, you will get something. So let's take this and graph it. Now, how am I going to do this easily so I can, all right, give me a second so I can just rewrite this. There. That makes it a little easier. So now I can pull this up. Now this one is not going to be two linear functions. This is a quadratic with a linear. So let's take a look at what this is going to look like at these on this graph. So let's make this one green, and let's consider making a table. Now, how can you get a table? You can plug values in, or you can get them off your calculator. So let's pull that calculator up and see what they say. So this is what it would look like if you graph this in your calculator. So if you pulled up your table, you could see how your numbers here would be 1, 2, 3, 4, and it says until 4, so we know this is going to be 1, 0, 1, 4, and at 0, it's also going to be at 4, because we know that this is our vertex right here. So we know that these will be symmetric. So let's just take this now and move this out of the way. And graph these. So this was a green function. So 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. So, but if we look, remembering right here, at 4, it's going to be an open circle. So let's change this one to an open circle. So this is what this is going to look like. Now remember, this is going to keep going. That's going to keep going, because there's no bound on the left-hand side. So now let's look at the second part, which we said is going to be, now we didn't say what color it's going to be, but we'll make it blue. So we're going to look at this one, x and y. This is easy enough to do a table with, or you could simply just graph it on your calculator. But let's look and see what happens here at 4, 5, 6, 7, because it's greater than that. So half of 4 is 2, and 2 plus 2 is 4. Let's do the friendly numbers. I'm not going to do 5. So do half of 6 is 3, and 3 plus 2 is 5. And let's do one more. Let's do 8. Half of 8 is 4, and 4 plus 2 is 6. So 4, 4. So actually, if we take a look at this, there actually is going to be a solid point here, but it's not going to be part of the green function. Obviously, if you're doing it all in the same color, you really won't know the difference. But 6, 5, 3, 4, 5, 6, 5. And then this way, and that keeps going because there's no bounds on the right-hand side. And this is our g of x. Looks pretty cool, right? So write down what you need to. And I think there's one more exercise. Is there? There is not. It's independent practice now. Okay, so if you want to do some of the independent practice at home, feel free to. But otherwise, we're going to come into class and get it done in class together. All right, so next time, until next time, always make good choices, and we'll see you then. Bye.